Okay, so we're going to talk about the square roots and the nth root functions. Now, the nth root and the square root, essentially, you know the square root as something that looks like that. And the nth root is going to be the same thing, but with an n or a number out in the front. And the one that's a square root is looking like this because basically we use it so often that we don't write the 2. But really, if you wanted to, you could throw a 2 out in the front like that. Just make sure that you can read it because most people won't write it. We've done this one before. We haven't done this one. Remember, what you're looking for is groupings of size 2, 3, 4 of size n, where we're having multiplication. So 2 times 2, we can pull out a single one under a square root, and so forth. So we'll do more examples of that later on. Now, what we want to do is look at functions that look of that nature. So if we have something like this where n is even, then remember, this is something that we did at the very beginning where the domain has a restriction. So you need the inside here to be greater than or equal to 0. So it can be 0 or it has to be positive. If we have an odd, then this part over here, it doesn't matter. Because, for example, the third root of negative 8, this is negative 2. Because negative 2 times itself 3 times gives you negative 8, which is on the inside. So what we want to do first is look at these examples and figure out the domain and whether or not the function can be evaluated at the points. So here, the domain has restrictions. X minus 2 must be greater than or equal to 0, right? So the inside is greater than or equal to 0 because this over here is even, right? It's a 2. So we can go ahead and just solve that. So X must be greater than or equal to 2. When we have the domain written out, we need to write it in its integral notation. So the domain is given by 2 to infinity, and this is actually a bracket because of that. Now the question is this in the domain? Well, one is, if we draw it out, our domain is like that, right? It's to the right of 2. This point over here is right there. So this does not lie in our domain. So we can't even solve it. It's done. This is not possible. So this point, the 1, does not lie in the domain. Done. The second one, we have a third root of n plus 1 minus 4. And that function, it has an odd, right? An odd square or odd root. And if we have an odd root, the domain is automatically negative infinity to infinity. So it's really nice about the odd ones is there's not any work to do, right? There's no math. We just write it as the domain is negative infinity to infinity. So because of that, the domain is everything. We can automatically find whatever plugin we want. So we want to find g of negative 2. Whenever we plug in, we replace all the things we plugged in with a parentheses. And then we plug in the minus 2 into there. Now, if you want, one way to help yourself sort of organize where the roots end is by drawing like this little line that goes up and down. So you know you can separate for example, the minus 4 there, and you know that it's on the outside. So simplify this. The third root of minus 1, minus 4. And this one is asking you, remember, what times itself 3 times is going to equal the negative 1. And that's going to be negative 1. So the answer in total is going to be minus 5. If you wanted to do it the other way, where we want to find out write out the multiplications, you can do that. And what it would be is the third root of minus 1 times minus 1 times minus 1, minus 4. So minus 1 can be written as a product of minus 1's 3 times, because this will give you plus 1 and then minus 1. And then you'll get the same answer. Either way is fine. What you'll find though is this way, if you can do this one, will help you when we do some of the bigger problems. But in smaller problems, understanding what times itself 3 times or what times itself 2 times gives you the same number is going to be easier.